So opening tracker on this Windows machine. Then need to go File and Import, and import a video. Now it's best you keep your video files and your tracker files in the same directory, just because it makes life a little bit easier later on. The file I'm wanting to load is Pendulum, so I'll just click Open and it starts to load. You see the large number of files here. You don't want too large a file, so be very careful if you're using large files or files of high number of frame rate, with a high frame rate. So I've got a high contrast target, and what I want to do now is bring down the axes from the top and put it over the pendulum. The pendulum in this position is okay, and I can tilt it, as you can see, for any inconsistency with the angle of the camera. But it's also better now that you can zoom in and move the center of the axis onto the center of your target, and once that's done, just click and come up to the top and take the axes off. You also want to have a calibration stick, so you're going from pixels into real world units. So again, zooming in, I've got the ruler there, and you follow the instructions there in the yellow at the bottom right hand side, where you click at the top of, I'm going to click on the 30 centimeter mark and then go down to the 20 centimeter mark for the second click, and then change the units from the suggested units, which will probably never ever be right, to 0.100 meters in this case. With that done, I can take the calibration stick off and zoom out. One thing you might want to do is consider, if you're using something like a GoPro or something similar, you can change the filter. It uses a filter in this, well, it's called a filter, to change either perspective or radial distortion. I think perspective is probably the one you want to use, but this one's okay, so I won't need to do that. Now we want to select the actual film that we want, so we're not wasting data. To do that, go down the bottom here and drag the marker on the bottom to where I, in this case, release the pendulum bob. And once that's done, I could clip the right hand side of the track, the end of the video, to make sure we're not missing, not taking any more data than we necessarily need to. Now let's have a look at what we're trying to so we're going to create a point mass, which is by default named mass M, mass A, and we actually want to auto track it. If you notice on it says click mouse to enter, but by shift control clicking, you get this up, which is the tracker software. You can do it through the menu, but you see what we're doing. We're wanting a nice obvious delineation between our target and the background, and the box, I've changed the size so it's searching in that area, and as you can see, it plots it as we go by tracking the object in there. Now this will, and I think it does in this case, it does actually come slightly aside because it does evolve over time. You see the 20% evolution rate on here. That's just to allow for marking. So I've jumped ahead And you can see how the edge of my target zone is slightly to the left of the centre where I wanted, but it's okay for the illustration of what we're doing here. And I'm changing now the mass to what the actual mass of the pendulum is, which is 96 grams. And this is quite useful because you can change the display from just being an X position to something like, say, the momentum or even the kinetic energy. So you can see the drop down menu there, and you can see the units are shown, and again we can change it to kinetic energy, and again the units are as described on the axes. So back to X position. In this next bit, I'm going to show you some of the functions of the tracking and so on, because it's all as it's all been done. These dots represent the trails, as they're called. So if you come up to the top, we can take these trails off by clicking and clicking no trails. Again, at the top we can come across and take the numbers off, or take the marker off, which is the little red dot, or we can change it to put a velocity vector on it. And you can see the velocity vector is not very large, so what we want to do is increase the size of it by applying a stretch. So I think an 8 times stretch there, and now I'll zoom out so you can see the full effect. And you can see how the velocity vector changes with the position of the pendulum bob. We can also take that off and now do the acceleration vector, and this is even smaller. So we'll need to increase that by significantly more, so 24 times, and then we can show that the velocity vector, the acceleration vector, is greatest at the extent in magnitude. And we can put both on at the same time, which is quite an interesting visual display. And if you have a look at the side, you can see both the plot view and the table view, but you don't necessarily have to have them plotting the same thing. So I've got two things like velocity here. I've got the magnitude of the acceleration, or if I now click on acceleration, so we can show velocity and acceleration. And here it is in more detail by sort of click on the left hand side, the little arrows where it says track control. You can see that you can show how this works in a far clearer format. So it's position and acceleration. You see there, 190. And let's change the top one again to velocity, and you can see that the relationship is pi by 2 out. Just to go through this a little bit more, we can use the step pause and advance the step on the bottom right to either go forward or backwards 1 frame at a time. So you can see the highlighted coordinate on each of the displays is moving 1 unit each time it's clicked. And that's quite useful to highlight the, say, the peaks and show where they occur and where the minima are. And again, we can do a similar sort of thing with the displays. You can expand them just by clicking on the two little arrows at the top left hand side, and that shows you can have a whole display. Now you might want to consider plotting different units. So instead of just having velocity against time, you could plot, say, velocity against the x position, which is intriguing. So this is plotting x against x, which is going to be a straight line of 1. Going back to x against velocity and now acceleration, which is this. You might want to think of these in terms of Lissajous figures. Right, if you click on table view, we can actually take the data, and you notice I've got an Excel open at the bottom. If I now click on the time column to highlight it, Control C to copy, and then Control V to paste into the Excel document. And similarly, go and do the same for the X position. This seems to work a lot better than trying to use the export the data files, at least in Excel. At least that's what I've found. And from this you can do your own data analysis.